we put in these jobs to monitor the planetary system over the course of 2 weeks. So presumably there was a point to doing that, and there was, as we'll find out. We have two main goals for this lab. 2.5 main goals for this lab. So first thing we're going to do is we're going to take those images, we're going to make a little stop motion film. There's not anything really scientifically relevant that could be gained from that. It's just kind of cool, kind of fun. We play with some tools in Afterglow. The next thing we're going to do is we're going to use measurements taken through those images to sort of analyze the dynamics of this system. Right? So you have a planet with a bunch of moons in orbit around it. And we're going to make measurements of the distance that the moon, one of the moons, is from the planet over the course of a 2-week period. And using that information, we'll be able to figure out some things like the mass of the planet and all this other stuff. So that's sort of the second, sort of the main section of what we're going to be doing today. And the last part is we're going to look at the face of Venus. So you didn't get to collect images of Venus, but we have sample data to work with. And you can make some measurements of the phase, and that tells us some very definite things about whether or not the geocentric or heliocentric model of the universe or the solar system is accurate. So it should be, it's a pretty interesting lab, I think, and maybe throw in the movie making just for fun. So we just take a look at the actual lab. So hopefully you guys read through the background. You've put in this job, you put it in 2 weeks ago, and so now you've got hopefully a handful of images back. You should have, at a minimum, 3 or 4 to do what we need to do. The more you have, the easier it is. And we'll see why that is in a few minutes. The first thing we're going to do, and this is less for science and more for fun, you're getting all these images back so we can do some cool things with them, first of which is to make a movie. So we have a couple processes in Afterglow to create a movie. So first thing we have to do is we have to align all the images. So we have this process called the align tool, which will find the center of the planet based on the light coming from it. And it will find the center of the planet in each of the images that you tell it to, and it will adjust them so that those centers are all in the same spot. So that when you go to make your movie, your planet isn't jumping all over the screen, it's all centered, and you see a nice little stop motion animated film. So one quick thing just regarding our data before we do that. So you have this in your observation manager. You should have your observation of Saturn that you set up to take images over a 2-week period. And you probably see something like this where you get a couple images and then maybe you have a few nights where you didn't get one and then you got some more. So just the reason I'm pointing this out, some of you or many of you may have put in to have 2 images taken per night. So in my case, I didn't. I just had 1. So you'll see, there's 1 image in each 24-hour window. You might see that there'll be 2 in a row that are like between the 15th and the 16th. So these will be the exact same time frame. If that's the case, you only need to use 1 of those when you go to make your movie. When we go and actually take measurements, you can use both, or you can just use one or the other, and that'll make more sense when you do it. But just kind of have in your head, if you got back 2 per night, just know, okay, I'm either going to use the even ones or the odd ones or whatever. I'm basically going to not use half of them. So that's just kind of the caveat to point out. So if we jump over to Afterglow then, we have a tool. So if we go to Process and Align, this will bring up our little alignment tool. And if you're following along, try to hold off for a minute just because it gets a little bit bogged down if everybody's trying to do it at once in the same location. But just kind of follow along in your head. And so what we're going to do is we're going to use this tool. We're going to add in the files that you took. So you go to Add Files Folders, and then you navigate to your images and to the folder for wherever the images of Saturn you have. So mine's just called Saturn. Yours might be called Saturn Lab 3, whatever it is. Then you just want to select all these. So just select the first one, hit Shift, click on the last one, and that'll select them all. If you are only using half of them and you only want to pull in half of them, you can use Control and just click every other one. Just hold down Control, etc. So it just depends on what you're doing. So once you've selected them, they should pop into this little window. and we hit next. This is our actual alignment tool, so you should see two things here. The left is just an image window, so this just shows you what this first image that's highlighted looks like. Over on the right, you have a list of images, and then you have a bunch of options for the alignment tool. It tells you how to do this in the lab, what exactly you need to use. I think it tells you that you can use any of these three options. I'm going to recommend using intersection. I've seen some people when they use the union option, it just gets a little bit weird when they go to make a movie. So basically the difference here is that in one, you're only using the intersection of the two, so where the two images overlap once they've been aligned. And in this other union method, you're using essentially everything. And so you can fill in some space and kind of just go through it. I'm using the 1 star because we're only aligning to the planet. In later labs, we'll have to do a 2-star alignment where we're aligning to 2 different objects across the screen. And you want to use the planetary method. Before we actually move on to working with the images, you need to select the target directory. So this is a place to tell the program where you want it to put these processed images once it's processed them. So if you hit that button, it should open up into the workspace. Now likely you're going to have nothing in here, no folders or anything. And so you should create a folder, name it whatever you want. I'll just name mine demo. And then you have to actually double click and open that folder. If you just click it, highlight it, and hit select, it'll just choose the workspace and not the folder you just made. Okay, so now we're ready to actually process these images, and in this tool, all you really need to do is just tell the program what the object is that you want to center to. So just click on the planet approximately in the center. It has an algorithm for finding the center, but just give it an idea. And as you click, it'll go on to the next one, and you just click through them all. It'll take a couple minutes, depending on how many images you have. So, like I said, there's a couple options for how you handle if you have 2 images per night. One is to only open up half of the images. The other, if you were to just open up them all, let's say that this 0 and the 001 image were from the same night, I could just take and reject one of them. So if I come back here, you'll notice that the first one has a nice little X on it, because it's selected and it's telling me this is where the center of the star is. If this one were from the same night, same location, I said, okay, I don't really need this one. I could just use this reject button. You'll see big X, reject. I'm not going to do that. I'll actually use it. So it's pretty straightforward. So once you get through this, the little next button on the bottom right corner of that screen, once you get to the last one and click it, should be highlighted. And you hit next. It'll take a minute. If you haven't processed every one of the images, that next button won't be highlighted. So like if you wanted to skip one and you just didn't click on it, you didn't click on it and you didn't reject it, you just like skipped over it, and it's like, wait, there's an image that you forgot about. And so this is just telling me that they've all been aligned and they've put in the folder that I asked them to. Click OK, now close down. So that's the align process. The next thing you're going to do is you're going to take all those images you just aligned, you're going to make a movie out of them. This is very similar. Pull up a little window, add files and folders, and it should automatically open you up to the folder that you just plopped all those images into. So again, you just select them all. Next. This will load up. And if I just hit play without adjusting anything, it should run through and make a little movie. It's going to take a little minute. It'll start to move, but you'll see the little hourglass will still be going, because it's like processing it through. It needs to go through a couple times to really know what it's doing. So you can kind of see, the orbital motion. You can see the moons going around the planet. You can see it revolving. So obviously it's not a quantitative measurement, but it's just fun to do. It's kind of cool. Obviously, the more images you have, the smoother this will be, or the closer spaced together they are, the smoother it will be. The only other thing you need to do, so you're going to be asked to submit a movie in which you can see the planets moving. So if you didn't adjust anything, obviously you can see the planets, but just like in Lab 1, where we played with histogram to bring out the most moons or make them the most visible without being overshadowed or washed out by the planet, you want to do that here. Okay, so you can open up the histogram and just set it how you want. Maybe I decide. Maybe I decide that's the best. That. But whenever you adjust it, just be sure to hit this equalize histogram button, and that will just apply that change to all the images, rather than just the one you have open. So whatever, play with that. Get it to where you can see all the moons, and then you're going to download the movie, and that's what you're going to submit. One note: so it doesn't matter which format you download it in, Move or in PBI, but sometimes it will not put the file name extension on, so you might have ran into this in Lab 1, didn't put JPG on or whatever. So this time it did for me, but occasionally it'll just like pop up into your computer like this, and so just add it. Whatever you selected, whether it was an AVI or .move, just manually add the file name extension before you save it. And it'll work. If you download one on your computer and you find it can't open, that's most likely the problem, so just try it, renaming the file with the file name extension on, and the computer will know it. Any questions? That's sort of the first little part, not very scientific, but kind of cool. So moving on, the next thing we're going to do is we're going to take actual measurements of our planetary system. So it's going to ask you which planet you observed, and you're going to go and you're going to pull up the best image of the ones you took. File, open image. You want to go to your actual images, not the line ones. You don't necessarily have to look at all of them. If you open up the first one and it looks decent, that's fine. And you want to adjust the histogram to min-max and measure the angular diameter. So this is something that you've done before. Your little tool. And again, like we did in Lab 1 with Saturn, you want to measure to the rings. And then this angular distance, we're going to put into the lab. And we're going to need that to figure out the physical diameter of the planet. So the next thing, the only other thing you need to do for this part, so once you've made this measurement, you need to open Stellarium and figure out the distance that it was. So the distance of all the planets changes, sort of day to day or as we're all in motion. So we need to pull up Stellarium and punch in the day and time of this image, window, image info, navigate to that time. And then you just find the planet. And you'll see this value, distance right here. That's the distance that Saturn was from Earth or from your viewing location at the day and time that you took that. So you want to use that value, and you don't need to put in 9.21087, the whole thing. Just first decimal place is fine. You plug that in here, and then you're going to go ahead and solve for the physical diameter. And so that's kind of the first section. Next thing you're going to do is you're going to go ahead and measure the actual orbital parameters of the moon. So again, you're going to need to have Stellarium open, and for Saturn, you're going to be measuring the distance to Titan. And so if I were to take and adjust this image, adjust the histogram down so I could bring out the moons. can then compare it to Stellarium. And now I can tell which one is tightened. So you always want to be measuring to the same moon each time. It tells you which one to do. Well, it's tightened because you all did Saturn. So you just identify which one's tightened, which is this guy down here, based on what we're seeing. And then you want to measure the distance from the center of the planet out to the moon. Now, what are some potential errors with this measurement that you could identify right off the bat? I'm holding true to my promise of giving lots of hints for the error section. Any ideas? Sorry? Yeah, so you're estimating the center is what he said. Meaning that they're asking you to measure from the center of each, and it's not exactly circular, and you're not exactly using anything other than your eye to find it, so those sorts of error, that estimation. But that's the idea. You want to do that, make that measurement for each of the images that you have available. You're going to input the system date and time, which you get from the image inflow in Afterglow, and the angular separation in arc seconds. This value right there. Do that for all of the images that you can. Like I said, the more data points you have, the more of these observations you have, the better. And then in the last part of this section, we're going to go ahead and make a graph. So our favorite little plotting tool, we use the moon option. So this is some sample data. So each of these data points is the distance of a moon from a planet. And on the x-axis we have time, or Julian days. Y-axis is the distance, or the angular separation in arc seconds. And so you see it's getting further away and closer as time goes on. And this green line is a curve that is fitted based on these parameters here. So semi-major axis, the period, the phase, and the tilt of the orbit. And the idea of this part of the lab is to adjust these parameters for this green curve until it fits to the data. And once it fits to the data, then you know that those are the parameters for the system you're looking at. So in this example, the first thing you're going to want to start out with, or that I usually start out with, is the semi-major axis, because that sort of like defines the height, the amplitude of this curve. So you obviously don't want semi-major axis significantly greater than whatever the farthest point is of your moon from the planet. So I just adjust that down a little bit. Maybe that's good. And then the next thing I usually try to do is adjust the phase. So the phase will just shift the curve to the right or the left. Won't really change the amount it's separated. But if you notice, I kind of lined up here on this left side, but it's a little bit short on this side, which means I need to increase the period of that curve. So that's pretty close. That's pretty good. Your data, it's not going to be this perfect. This is obviously like some generated data. But this is what you're going to want to have at the end of the day, or something similar to it. You want as many points as you can, as many of your data points to fall on the curve as you possibly can get. And then, again, it's a graph, so label the title and the axes. And if you notice at the top, it's kind of hard to see, but right next to the plot title, it tells you the value for A and P, which are the semi-major axis and the period. And those you're going to need to figure out the mass of the central body. So the mass of that central body determines sort of the dynamics of that orbit. By figuring out that information, we can work back to this. Any questions on this part before I'm done? Be patient with it. I have to like adjust them slowly and get it there. It's not going to be as easy as this one, obviously, this is an example data. Go back to the lab. So then you plug in those values and figure out the mass of the planet. So that's sort of the bulk of the lab. The last section is to make some analysis of the phases of Venus. And so in this section, like I said, you don't have any images of Venus, so you're going to be working with sample data. Go to Open, and navigate back to the home directory. You can see there's a sample images directory. Open up the Astro 101 lab folder, lab 3, Venus. And you're going to want to use all these images, but I'll just open up. Open up. Save this. And so what you're going to be doing here, if you look at our lab, the phase is based on the ratio between the illuminated and angular distance. So the part of the planet that is illuminated versus the true angular distance or the full angular distance. So that's the phase. So you just want to measure, make both those measurements, find the phase for each of these images. And so if I just adjust the histogram down, so there we go. It's a min-max, that's min-max, and zoom way in. You can see that you can make measurements of those two values. Zoom in as best you can. This would be approximately the illuminated. Obviously, there's some gray area there, so use your best judgment. And then the full distance is basically straight across. Or something like that. So you're going to make those measurements, plug in those values for all the images, and then you're going to compute the phase. One thing to just note, the phase, it's a ratio, right? So it's the amount of the planet that is illuminated over sort of the total size of the planet. And so what's the maximum that the phase should ever be? What would it be for a full moon? 1, right? So it should never be a number greater than 1. It should always be less than or equal to 1. And you have to plot that information as well. That's the Venus option here. Plug it in and it's pretty obvious from there. Questions? Okay, cool. Get started. I'll be here.